Assalamu alaikum and hello everyone. Welcome to today's talk on an interesting topic from engineering mathematics, that is the rate of growth and decay. This idea helps us understand how things grow or shrink over time in real life. Myself, Abbas Mashakini, and I am a first year computer science and engineering student at Sri Venkateswara College of Engineering, Bangalore. Let us dive into the topic and see why it is so useful. Introduction. Have you ever wondered how population grow or how materials like radioactive substances break down over time? That is what the rate of growth and decay is about. Growth means things increase, like population or money in a bag. Decay means things decrease, like the trading of a radioactive substance and money in a bag. This, this topic isn't just maths, it is important in biology, physics, and finance. Today, we will look at how this works and why it matters. Mathematical formulation. Let us look about the math behind it. Here, you can see the formula to calculate the rate and growth, where y naught is the initial value. This represents the starting value of the quantity at time t is equal to 0. It is the base, it is the base amount from which growth or decay occurs. Now, the variable k. Growth, it is known as growth or decay constant. This crucial parameter determines the rate of exponential change. Positive value of k indicates growth, while a negative value indicates decay. The magnitude of k signifies the speed of the change. A larger absolute value of k means faster growth or decay. T. The variable t is time. This variable represents the independent time in the equation, indicating the elapsed time since the initial value. The units of t must be consistent with the growth or decay constant k. Example, years, months, days, etc. The variable y. Value at time t. This represents the value of the quantity at a specific time t. It is the result of exponential growth or decay process, calculated using the formula y is equal to y naught multiplied by e raised to power kt. It shows how the initial value has changed over time t. Rate of growth. Now let us talk about growth, where examples include how population increases or how money grows with compound interest. Starting with 100 individuals and a 2% annual growth rate. After 5 years, the population will be approximately 110.5. Now, let us talk about the compound interest example. If a $1,000 investment at 5% annual interest is done, then it will yield approximately $1,629 after 10 years. We can clearly see that over time the population doubles and keeps growing faster. This formula shows us how growth can be speed up as time goes on. Now, rate of decay. Now, let us look at decay, where examples are radioactive decay or cooling of hot objects. Take a radioactive material with half-life of 10 years. Using the same formula, we can find how much it is left after some time. The graph will show a steep drop getting smaller and smaller as time goes on. It is amazing how math can be described this so accurately. Now, let's talk about the applications. Growth and decay have many uses. In biology, they explain how bacteria multiply. In physics, they show how radioactive substances break down. In finance, they help calculate how a car loses value over time. For example, if a car value drops by 10% every year, we can predict its worth in 5 years using the decay formula. These examples shows us how this math connects to everyday life. Common misconceptions. Let us clear up a few misunderstandings. First, growth doesn't mean that things can grow forever. There are always limits. Second, decay doesn't mean that things vanish completely. They just get very Lastly, is a special number that helps describe natural growth and decay. By understanding these points, we can better use this concept. Summary. The rate of growth and decay is shown by the given formula. Growth happens when the quantity increases over time. That is, the variable k is greater than 0. Decay happens when the quantity decreases over time. That is, the variable k is less than 0. This idea helps us understand things like population growth, radioactive decay, and financial changes. With this knowledge, we can explain and predict many real world situations. Before we finish, let's think about what we have learned. Here are two quick questions for you. What does k is equal to 0 signify in the growth and decay formula? What is the half-life of an isotope? Can you name a real-world scenario where exponential decay is observed? Take a moment to think about this, and you can answer all these questions in the comment section below. I will be providing the answers in the description below because it is crucial to ensure the concepts are clear. Thank you all for listening. I hope you enjoyed learning about the rate of growth and decay. If you have any questions, feel free to ask. It was great sharing this topic with you. Thank you. Thank you all for listening. I hope you enjoyed learning about the rate of growth and decay. If you still have any questions, feel free to ask. It was great sharing this topic with you.